Today we're talking about direct variation. Now, two variables have direct variation if they can be written in the form y equals a times x. So a is called the constant of variation. Now, another way of looking at this is y over x equals a. That's what we get when we just divide both sides by x. And so when you take all of the y values, divide them by the x values that go with them, if you get the same thing or very, very close to the same thing over and over again, then the two are directly related and you can write them in this form. Now notice this looks just like a linear equation except for the y-intercept is 0 because there's no constant term over here. And that constant of variation doubles as the slope. So to see if an equation can be modeled with direct variation, we want to rewrite it in that form. So if we're given 2x minus 3y equals 0, we want to solve for y. So we subtract the 2x from both sides, gives us negative 3y equals negative 2x. Then we divide by negative 3. We get y equals 2/3 x. So this is in that direct variation form, and 2/3 is our constant of variation. An equation that looked like this, though, when we rewrite it as y equals by adding x to both sides, we get y equals x plus 4. Now this has a y-intercept of 4, and so this is not direct variation. And so since it's not direct variation, we don't even have to worry about finding a constant of variation, because there is none. Now graphing direct variation is the same as graphing any other line. The only difference is that every time we graph a direct variation equation, our y-intercept is at the origin. So if we're given the equation y equals 2/3 x, we simply start at the origin and we use our slope of 2/3. So a rise of 2 and a run of 3 puts our next point at 3/2. Or if we went backwards, negative 3, negative 2. Then all we have to do is connect the dots to form our graph. In another example, if we're given a point, negative 1, 2, and of course it has to pass through the origin if we're looking at direct variation, and we want to write a direct variation equation that solves the model, or that models the graph here. So we're looking for y equals ax. Well, if I have the point negative 1, 2, then I know that when x is negative 1, y has to be 2. Which means that a has to equal negative 2. So my equation is y equals negative 2x. Then I could use that to find the value of y when x is 30 or any given x value. So y equals negative 2 times 30. So when x is 30, y is negative 60. Example 4 in the book says that the number S of tablespoons of sea salt needed in a saltwater fish tank varies directly with the number W of gallons of water in the tank. A pet shop owner recommends adding 100 tablespoons of sea salt to a 20-gallon tank. So if we have water in the tank varying directly with the amount of salt. So let's use those numbers that were given. 20 gallons of water for 100 tablespoons of salt. If we divide both sides by 100, we find that our constant of variation is 1/5. So we have W equals 1/5 S. Then we want to know how many tablespoons of salt should be added to a 30-gallon saltwater fish tank. So if we put in 30 for W, because we're looking at an amount of water, and we multiply both sides by 5, we find that for a 30-gallon fish tank we need 150 tablespoons of salt. The last example in this lesson gives us a table which says the number of songs we download, 3, 5, and 7 songs, cost us $2.97 for 3 songs, $4.95 for 5 songs, and $6.93 for 7 songs, and we want to know if if the cost C varies directly with the number of songs S. So if it did, it would fit this equation, which means that C divided by S would be our constant of variation. So what we do is we check all of our C's divided by all of our S's and see if we get the same thing. So if we divide 2.97 by 3, what do we get? 99 cents. If we divide 4.95 by 5, what do we get? 99 cents. And if we divide 693 by 7, what do we get? 99 cents. So since we have the same thing each time, not only does that tell us that this is a direct variation equation, it gives us our constant of variation, 99 cents. And so there is our equation. Alright, if you have any questions, feel free to ask. If you need something clarified, you can go back and watch the video again. Otherwise, you can move on to your homework.